Here you want to work out the median from a grouped frequency table. You've got to observe that there are gaps in between the classes. Okay, so that means you need to use lower and upper bounds when you're doing interpolation. Q2, or the median, is the value that lies halfway between the data. So you've got to do half times the total frequency, which is 120. And that means that the median is the 60th value. If you were to organize all of your data in the list from lowest to highest. Next thing you need to do is work out which class that median lies in. So list the cumulative frequencies down the side. You've got 10, 29, 72, 97, 105. Okay, so the 60th value must be in this class. So draw your line, mark on the boundaries of that class, which are 19.5 and 29.5. Put the cumulative frequencies at the bottom. The 60th value would come somewhere about here. So to work out Q2, we can say that the gap between Q2 and 19.5 over the total gap is the same as the gap between 60 and 29 over the total gap. And that gives you Q2 is 26.7. The next thing you need to do is to work out the mean and the standard deviation. You've already been given total fx and total fx squared, so you don't need to use the stats function in your calculator. You just need to recall the formulae. So for mean, it's total fx over total f. So you need to do 3550 over 120. And that gives you 29.6. And for the standard deviation, you've got the formula total fx squared over total f, take away mean squared. So that's going to be 138,020 over 120. Take away the answer squared that you got for the mean, and that gives you 16.6. Okay, so part C says, should you use the mean or the median to represent the data? Now you can see that the median is slightly lower than the value that you got for the mean. And you can see why when you look at how the values are distributed in the table. You've got a bit of a cluster of values here for the lower distances, and then you have a handful with much higher distances over here at this end of the table. So what that suggests is there are a handful of commuters that are traveling very big distances, but not the majority. And what those handful of values here do is they skew the mean and they make it larger than it really should be. And that's also true for the standard deviation. So the more realistic measure to use here would be the median. Part D, under what circumstance would it not matter whether you use the mean or the median? They would be exactly the same if it was a symmetrical distribution. So one where there was no skew or no sort of majority of values at one end or the other.